Hello, welcome to Z-Talk. In this session, I'd like to discuss about an open source distributed tracing solution, Jaeger. If you watch my previous videos, we've discussed about Prometheus, Grafana, and Loki, which basically covered two pillars of building our own observability platform, which is metrics and logs. However, as we know, the downside of the modern microservices architecture is complexity, making it more difficult to quickly diagnose and resolve performance issues or errors that impact customer experience, right? So to be able to quickly understand what happens to requests as they transit through the microservices that make up your distributed application, we're going to introduce uh, distributed tracing. So what is distributed tracing? Um, it's the capability for a trace solution to track and observe service requests as they flow through distributed systems by collecting data as the requests to go from one service to another. The trace data helps you understand the flow of the requests through your microservice environment and pinpoint where failures or performance issues are occurring in the system and why. And combining traces with the other two essential types of telemetry data, which are metrics and logs, gives you a complete picture of your software environment and performance for end-to-end observability. All right. Jaeger. Okay. Jaeger is the most popular open source distributed tracing backend. It was created by Uber. To get us started, I'd like to talk about what a trace is and how traces are generated and some important terminologies about tracing. I think understanding what traces is helps us understand the Jaeger ingestion pipeline the way that it is. All right. Okay, let's start with terminologies. Span. A span is the hierarchical building block of a trace. It represents a collection of performance metrics and logs for a single interaction with a service. Um, a trace, on the other hand, is a collection of spans that represent a single user transaction. It could be a HTTP request or an asynchronous message for launching a job, for example. Tracing depends on context propagation, like the graph shows. When a request comes in through an edge service, it is stamped with an unique trace ID, and this trace ID might contain additional fields or we can call them contexts. These contexts are then propagated to every service in the code chain by using headers or other similar mechanism. So altogether, traces can be heavyweight, because spans can have arbitrary tags placed on them and can read or write to context that can be propagated in the application. So being said of that, saving everything incurs large storage cost along with performance overheads from instrumentation. Jaeger performs sampling by default because of that. This is the architecture of Jaeger. The application from, by the way, from left to right of my graph. All right, the applications are gonna be pushing all their spans from the Jaeger client into the agent. The client itself, it's a part of the application, like a library or a framework that you bring into your application to create these spans and offload them to Jaeger. There is a variety of applications or frameworks and languages supported by Jaeger, like Java, Go, Node, Ruby, Python, you just name it. So all these different enterprise languages have support for Jaeger. So you create these spans in your application using clients, which is then offloaded to the agent, and the agent then moves them over to the Jaeger collector piece, where you need to make a choice about how to set up a pipeline. Um, Jaeger uses external services for ingesting and persisting the span data, such as Elasticsearch, Cassandra, and Kafka. This is due to the fact that the Jaeger collector is a stateless service, and you need to point it to some sort of storage to which it will forward the span data, right? For production deployments, the current standard persistent storage for Jaeger is Elasticsearch and Cassandra. Um, as you know, both of which are very popular open source NoSQL database. The Jaeger collectors and query service need to be configured with the storage solution choice, as they can write to it and query it, right? So I guess the question comes to which storage backend should we use, Elasticsearch or Cassandra? Um, so the Jaeger team provides a clear recommendation to use Elasticsearch as the storage backend over Cassandra. They have very good reasons, and I found an article to explain that in detail. I'm gonna share it in the description of this video, so feel free to take a look if you're interested in understand more detail about it. So, but in general, like a summary of that article. So Cassandra is a key value database. So it's more efficient for retrieving traces by trace ID, but it does not provide the same powerful search capabilities as Elasticsearch. Effectively, the Jaeger backend implemented the search functionality on the client side, um, on top of key value storage, which is limited and may produce inconsistent results. On the other hand, Elasticsearch does not suffer from these issues, resulting in better usability. And what's more, Elasticsearch can also be queried directly, like from Kibana dashboards, and provide useful analytics and aggregations. On the other hand, one benefit of using Cassandra backends is the simplified maintenance due to its native support for data TTL. However, in Elasticsearch, the data expiration is managed through index rotation, which requires additional setup. So if you monitor many microservices and you have a high volume of span data, your external backend storage may not be able to handle the loads and may become a bottleneck. That's why we're talking about making a decision here to see if necessary to create a streaming strategy. So for this scenario I brought up, in such cases, you should deploy the streaming deployment strategy, which uses Kafka between the collector and storage to buffer the span data from the Jaeger collector. All right. Okay. Demo time. I'm gonna use the demo app provided by Jaeger to walk you through the configuration of each of Jaeger components. here. Let me see. Let me go to here is the Jaeger official website, and as you can see, it provides the images and the binary for download, right? So by the way, we have the option to quickly spin all up by Docker using the all-in-one image, which is designed for quick local testing. This guy. So it's pretty easy. All you need to do, you just need to pull these all-in-one image, and Docker takes care of the rest. So Docker gonna launch the Jaeger UI, collector, query, and agent all together with an in-memory storage component. It's super easy. For my demo, I'm not gonna use these all-in-one image. Actually, I'm not gonna use Docker. I'm gonna download the binaries and set up a simple environment for production. As I mentioned, the all-in-one use case is only good for testing on your local, as it uses an in-memory storage. For my case, like I explained in my slide previously, I will install Elasticsearch and use it as the backend solution. All right, and after that, I will walk you through my process of troubleshooting as example using the sample app Jaeger provided to help you get familiarized how do we utilize these tracing capability to find the performance issues in our application. Cool. One more thing before we jump to the demo, remember thumb up my video and subscribe my channel, and feel free to leave comments or any questions. All right, because we're gonna use Elasticsearch as our backend storage solutions, right? So we're gonna install Elasticsearch on my laptop first. I'm using Mac, so I'm gonna use Homebrew to install Elasticsearch. So it's pretty easy. So all I need to do is let me go to the terminal, and I need to add the Elastic tab first. So by issuing brew tab Elastic tab. And then we're gonna install Elasticsearch. By the way, if you're using other flavor of operating systems, just Google Elasticsearch download, and here you go. You can download for Windows, Linux, based on your environments. All right, and all right, the Elasticsearch is installed successfully on my laptop. So next, just gonna start Elasticsearch by this command: brew service start elastic. All right, let's double check by brew services list. And as you can see, the Elasticsearch is started. Cool. That's the first step, and then we're gonna download the Jaeger components along with the example application hot rod. So as I said, I'm gonna use this binary for my demo. So I just download this binary by clicking this button for Mac OS, And here we go. I already got all the binaries for each of the Jaeger components. Now I just need to start these components one by one. Just remember, by the way, I'm not gonna use these all in one because is for these all in one use case is just combine all components together and along with a in-memory storage storage components. So for me, I'm gonna manually start each component so it's able to connect to the elasticsearch as we planned, right? Let me just note here, because we have to manually start each of the components, there is a requirement for the sequence because there's a dependency between the components. So the sequence should be we start Jaeger collector first, and then agent, and then query. Because agent depends on collector. If we start agent first, it gonna throw an error saying it's not able to connect to collector. All right, cool. All right, let's start the demo application first. Here are the example hot rod. All I need to do is just run this executable example, and with the all arguments, basically this all arguments tells to start all the services inside of this application. Hit enter. All right, it's up and running. So let's verify by logging on to my browser. Just type localhost 8080, and here we go. This is the application. All right, looks good. And then let's start the Jaeger components one by one. Remember, the sequence is important because there's the dependency between each other. So we need to start the Jaeger collector first. So here we go. We need to start a Jaeger collector by run this executable. But along with its executable, we need to use a environment variable to point it to the backend storage solution, which is elasticsearch that we just installed on our laptop. So we need to add these environmental argument. Span storage type is elasticsearch, and the elasticsearch server URL is because I'm installed on my local, I'm using the default port, which is 9200, and run this executable, and I'm gonna add a prefix as open tracing in the Elasticsearch index. All right, looks good. Hit enter. The collector is up and running. Then the next we're going to start the agent. For the agents, we need to find a port to connect to the collector. So based on the documentation, we're gonna use these ports to connect to the collector via grcp. So what we need to do, we need to issue this command, ports for 14 to 50. Hit enter. Oh, by the way, if you're using Mac OS and it's your first time to run these query, you might got these error pop up is saying these executable cannot be opened because the developer cannot be verified, right? So if you run into these error pop up, here's the fix. So you need to go to System Preference and click Security Privacies, and oops, so let me cancel it. So go to System Preference and Security Privacy and General, and you can see I was trying to run these agent executable, right? So I need to click Allow anyway to unlock. Let's do that again. Hit Enter, and here we got an option Open. Just click Open. Then these executable was being executed, right? And you can see the agent is up and running, and is connected to the collector. And last but not least, we're gonna start the last piece, which is query. So let's go to the Jaeger directory, and we need to start up these query components. So for these query components, we need to, same thing, we need to define the environment argument variable. Storage type is like the search, and the server URL, and run this query, and same thing like what we did on when we start up the collector, right? And let's hit Enter. Okay, same thing. We need to go to System Preference and Security and Privacy, General, and Allow anyway. Alright. Run that again. Click Open. Cool. Now everything is up and running. So let's verify. Here, let's go open up the Jaeger query interface, which is localhost 16686. All right, this is the Jaeger UI. So let's generate some traffic by hitting any of these services in this application, and let's see if we can get trace here on the Jaeger UI. So I'll generate one, another one, another one, another one, and go back to the UI page, and let's do a refresh and select the service and just find traces. All right, here we go. So I generate 4 requests, right? And here we go. We can see there were 4 traces showing up here. So if we click here, we can see the detail of the trace. Cool. Perfect. And next, I'm gonna show you like how do I use these Jaeger UI to troubleshoot, to identify where is the bottleneck or the performance issue for these applications. I'll show you example what I'm talking about. One more thing we forget to verify was we didn't verify if the span data was feeding to Elasticsearch storage as expected yet, right? Let's quick verify by issuing this curl command. So basically just search for indexes in the Elasticsearch, right? Hit Enter, and as you can see, there were 2 indexes were created, and the span data were storing to Elasticsearch as expected. Looks good. Cool. Let's jump back to the Jaeger UI, and as mentioned, we're gonna use a performance issue use case to demonstrate how do I use these UI for troubleshooting to identify the performance issue or the bottleneck of this application. And we can take advantage of this demo app because it's able to simulate different performance issues. Let me show you example. So here, back to the application side, let's generate, and it actually already generates a bunch of requests here. What's the difference you can see here? Did you notice like some of the request where the latency was pretty short. It's just a 700 milliseconds, but the other one, the next one, is almost 6 seconds. It's a huge difference between these two requests. So what caused this is definitely somewhere impact the performance. Here, let me show you an example. Generate one more request. Click this, and you can see the latency looks good. It's just around 8 milliseconds. Not a big deal, right? What if I generate more traffic at a short period of time, like this? Did you notice the latency is spiking? So what caused this spiking? Let's jump to the UI to dig in the traces. Here, let's find the good one, like these 700 milliseconds. This looks good, right? So as you can see here, the SQL only my SQL query, it took about 300 milliseconds. Let's compare with the another trace with the word latency. So like this, go here, and here, and you can see for these SQL query, it took about 1 second. So what caused this issue? So if you click for detail, click expand the logs, and you can see these events. It says waiting for a lock behind 4 transactions. Let's go back to the good one, like this guy. Expand these SQL log, and you can see here acquire log with 0 transactions waiting behind. That's basically the problem. Here, these SQL query was the bottleneck of this application, because when we generate like only one request, there was no queued up, so we don't have to wait. As you can see here, there was 0 transactions waiting behind. On the other hand, in another scenario, we generate a large amount of requests in a short period of time, and it's queued up. And back to the back to the newer trace, and you can see in the log is waiting for lock behind 4 transactions. Basically, the SQL query looks is only able to deal with one request at a time. If there are a bunch of requests in the queue, it's kind of queued up, and it's not able to process multiple requests at the same time. That's caused the latencies. That's caused the spiking of the latency here. So how do we fix it? Let's take a look what arguments available for these demo app executable. Let's run this, stop the application and run these demo again. This list out all the flags available for this executable. And as I said, these demo app is able to simulate different performance issues, and it also provides the fix of different use case. All right. So for our case, we just found out that performance issue looks like this is the fix, and you can see here this flag. It disabled the mutex guarding DB connection. So let's test it out. So what I need to do, I just need to rerun this executable at this flag -m. So basically, what it does, it just disable these property so that the locking behavior on the DB will not be there anymore. So let's see. So I include these -m flag and all to start all services right here. All right, let's see if there are any difference. Hit enter. All right, the application is just up and running now. So let's jump back to my interface and refresh. And now let's try to generate a lot of requests for different services. Okay, looks good. Around 700 milliseconds. Let's do more in a short period of time, like this. Did you see? So even I generate a lot of requests in a short period of time, but the average latency for each request is still around 700 milliseconds. As you remember, compare with the previous situation without including that -m, the latency is getting much better. There was no spiking basically for the latency for each of the requests. So let's take a look on the Jaeger side. Let's do a find trace and take a look the MySQL query, and you do not see that log, the logging, right? Pick another one, and you do not see that logging because it was disabled, right? That fixed that performance issue basically. All right. Besides the trace, there's other features like you can compare between traces like this. Select the trace you want to compare and click compare. It shows the difference. Here is the difference between these two traces. Other than that, the other feature is you're able to see the deep dependency graph like this. Sorry, the system architecture. Let me generate. All right. Click that. You can see basically it's the service map. It's able to show you the traffic flow from front end to customer to MySQL database backend. All right. That's basically what these Jaeger UI is able to provide. All right, and we can also do some filtering with more traces showing up. We can filter based on, for example, duration. I only want to see the trace where the duration is more than, for example, 1,000 milliseconds, or we can filter by tags. We can include, for example, like this, HTTP status code. I only want to see traces with a status code equals to 200, error equals to true, something like that. That's basically this UI, and this is what I want to share for this session. All right. Oh, by the way, before we call it a day, something just came up of my mind. I forgot to mention Grafana Temple. So it's Grafana's own distributed tracing backend. Basically, is using Jaeger technology behind the scene, but is Grafana's own product, is better integrated with the Grafana platform. So if in your environment you use Grafana, you use Prometheus, you use Grafana Loki, it may be worth to take a look at Grafana Temple. I tested Temple a little bit because it's kind of too new, because this product was just released late last year, and from feature point of view, it's still not that mature, and is provide limited feature. For example, you can only get the trace by trace ID. So you have to basically grab the trace ID from the log, for example, and paste it to the to the temple to grab the trace for that specific trace. Instead of on the Jaeger side, we can get all those traces, and there are like different like filter features available, which is currently not available on Temple. But from the long run, is I think it's worth to take a look. And if you're using Grafana and you're a fan of Grafana, I'm encouraging you to test it out a little bit. And it also provides the sample application or a sample test. So it's pretty easy to set it up. So take a look. All right, cool. Thank you for watching my video, and I'll see you next week. Alright, thank you for watching my video. If you think this video is helpful, you're more than welcome to leave any comments. Remember, thumb up, subscribe my video, and also hit the notification bell. See you next time.